Hey everyone. All right, so we're going to go over some problems that you will see on Thursday's midterm. We've only done a few lectures for this period because of everything. We want to make sure we were fair in the extenuating circumstances. So that being said, this shouldn't take too long to go over some of these basic types of things that you'll see. Also want to remind everyone that I do drop the lowest midterm. Now, if we were on Blackboard, I would have just been able to do this automatically, but I haven't figured out that functionality if there is one on Canvas yet. So what I'm going to do is I'm going to do everything kind of manually. So once everyone's done with the exam, I'm going to put a new column in that says your midterm points. And so that's going to take into account dropping the lowest midterm, and the midterm scores that are up now will no longer account for actual points. Okay, so I will do that by the end of the week, because we should be done with the exam by then. And let me know if you have any questions with that. All right, so let's take a look at some sample questions we might see. So we've got a monopoly problem here. And so first question you can imagine is, what output will the monopolist choose to maximize profit? Well, for a monopolist, they're going to choose to produce where marginal revenue equals marginal cost. Okay, and we've talked about this a few times. Why is that the case? Well, let's say it wasn't the case. So let's say they produce some amount higher, so about 8,400. Well, here marginal revenue is going to be 0, but marginal cost is going to be some amount near 5. So in other words, they're not getting any new revenue in, but the cost for producing this good at this level is going to be 5. So they're not going to want to do that. So they're going to reduce their production until that is no longer the case, which is going to be where they're the same. Okay. Thinking about it from the other end, if we produce less than that, so let's say we produce here at 7,000, so the marginal cost is very low, it's around 0, and the marginal revenue is around 5.5. So if we did that, well, marginal revenue is going to be greater than marginal cost. In other words, it's going to cost us less than we're going to get in revenue for producing one more good, so we're going to produce that one more good. So we're going to produce 7,001. And that's still going to be true, though. So we're going to keep producing until that is no longer the case, which happens where they're equal. Okay, so what we're going to do is we're going to find where marginal cost equals marginal revenue. That happens here at 7,500. We look at our answer choices, and we see that 7,500 is question A. Okay. Next, we ask, what will be the price the monopolist charges? Okay, so remember that in equilibrium, we could just find, wherever supply and demand equaled each other, and that was going to be your equilibrium supply and demand. Here, we find where they're equal, and that we find that to be our quantity, but we don't go across to the y-axis here. We don't do that. Okay, and the reason is we are willing to pay a higher price than that as consumers. Okay, we get that from our demand curve, right? This demand curve is telling us what we're willing to pay for this number of quantity. Okay, so we're willing to pay 7. Okay, so we just go up. We're saying at this level of quantity, this monopoly quantity, we go up to the demand curve, find out what people are willing to pay, and we see it's 7. So if we go to 13, we see 7 is one of the answers. Okay, so far so good. Next question is asking about profit, and then after that, dead weight loss. Okay, so let's see if we can figure those out. Okay, so let's see if we can find. Let me turn this into. Let me turn this into a bit of a highlighter. Okay, so what we're going to do is we're going to remember that profit. That one was already a highlighter. Remember that profit is going to equal. Oh, that's the one I just turned into one. Let's change this a little bit. All right, so profit, having some technical problems. Profit is equal to revenue minus cost. Okay, so what we've got to do if we don't want to remember exactly what the points that we kind of need to find the profit, just remember this equation here. Profit is just the difference between revenue and cost. In other words, it's how much we've got coming in, that's revenue, and we're subtracting out how much is going out, how much it costs us to make these products. Okay, so let's find each of these individual things. Okay, so revenue we define as just the price times the quantity. Well, we know what both of those things are because we found them in earlier problems, the two earlier problems. We found our quantity is 7,500, and we found our price was 7. Okay, so our revenue is actually equal to this box here. Okay, if we think about this as being length times width, profit times quantity, then the area of this blue box here, is actually going to be our revenue. Okay, so we've got part of it. Now we just have to find out what our cost is. Okay, so if we want to know what our cost is, well, let's take a look at what options we have available on our graph. We see we've got marginal revenue, demand, marginal cost, and average total cost. Average total cost is going to be how we figure out what our cost is, our total cost. We're going to extract the total cost from the average total cost. So how are we going to do that? Well, we can say that average total cost is equal to total cost divided by the quantity. Okay. Well, we know what the quantity is. The quantity is going to be 7,500. Okay, but aside from that, if we wanted to extract this total cost from this, well, what could we do? Well, we could multiply both sides by Q, and we would get total cost is equal to average total cost times quantity. Okay, so in other words, let's go over to the quantity, 7,500, and let's go up and see where the average total cost curve is. So I'm going to go up, and boom, I've run into the average total cost curve. And what is my average total cost? My average total cost at producing 7,500 units is $5. Okay, so if I took this average total cost times Q and multiply them by each other, just like we did before, so in other words, we're finding essentially length times width, then I found my total cost. Okay, and remember, profit is just the difference between revenue and cost. So this area here, well, that was way too big. Let's make this a little smaller. This area here is going to represent our profit. Okay, that's the difference between the revenue and the cost. Okay, so we could just think about this, straight from the beginning. This is just an easy way to remember where to go. Okay, and we can do this two ways. We could actually find out the area of the revenue and find out the area of the cost and subtract the two, or we could just find out the area of this block. Okay, so that's what I'm going to do. It's one step. We want to do length times width, and so let's look at both of our sides. So we're going from 5 to 7, so that's going to be 2, and we're going from 0 to 7,500, so that's going to be 7,500. So we're going to have 7,500 times 2, and that should give us 1,500. So let's look over here. Do we have that as an option? Yes, we do. Okay, so we're chugging right along. So next question is going to ask us about deadweight loss. Remember, deadweight loss is this potential surplus we could be getting if we were at the efficient level of production. The efficient level of production is where marginal cost equals demand. Okay, that's our old idea of equilibrium, right? But we're not here. And because we're not here, we're not picking up some surplus. Okay, so in particular, this area right here is going to be our surplus that we are not picking up. That is our deadweight loss. And it is equal to a triangle, which is 1/2 base times height. So all we have to do is find what our base and our height is, and we should plug and chug. Okay, so we're going from 7,500 over to 9,500. Okay, so that's 2,000. 2, 1, 2, 3. And we're going up how much? So this is about 4, and this is at 7. So we're going up 3. Okay, so it's 1/2 2,000 times 3. That's the same as 1,000 times 3, or 3,000. And we see that is an answer. And I'm gonna, for our sake, I'm gonna not spend too much time on number 16, but it should be pretty quick based off of the conversation we just had. If the monopolist was regulated at the efficient price, what would the price be set? Well, we said that it was just where marginal cost equals demand, right? So that's our old idea of equilibrium. And so we just go over to the y-axis and we see 6. So that's really all there is to that. Okay, so that's pretty much the basic questions for a monopoly. Okay, so this is more about regulation, which we're not going to deal with it in any more detail than we just kind of did. So let's keep going here. All right. So suppose you've received some bonds from your crazy Uncle Leroy. The first bond pays the holder of it $110 in exactly 1 year's time. The second bond is a forever bond. It'll pay $5 every year forever, starting in 1 year's time. Interest is 10%. So what is the present value of these two bonds? So this PDV, that's just present discounted value. Okay. So, for all these types of questions, the best thing to do is to write out a line, a number line. Okay. So let's do that. So let's state we're starting in time 0. Okay, we're going to get $110 in 1 year. So at year 1, we're getting $110, and the second bond, it's going to pay $5 for every year after. ... And this is going to infinity. Okay, so we're going to get $5, $5, $5. Okay, well, if we want to know the present discount value of both of these bonds at a rate of 10%, okay, then what do we do? Well, we know what the formula for perpetuity is. Okay, the perpetuity, we know how to use, we're going to use the perpetuity because he said we're going to get this $5 forever. Okay, so we know we need to use a perpetuity for that. And perpetuity is going to basically give us the present value, or at least the value at some time, the period prior to when the first payment comes. And all we have to do to do that is we say, well, what is the payment and what is the interest rate? And that's it for that formula. So the year prior to 1, which is going to be 0 for us. So in the year prior to 1, the value of this $5 forever is going to be 5 divided by 0.10. Okay, so I know we can do this in our heads, but I highly suggest we don't ever do these types of things in your heads. Use your calculators. So I'm just going to plug this in. I don't think you guys can see it, but all right, so 5 divided by 0.1, well, that's just going to be 50. Okay, always do this. Always do this instead of. I know these are simple calculations, but this is also where we make mistakes. I don't want you guys to make any mistakes. So we know that the value of this perpetuity now is $50. Okay, so now all we have to do is find out the value of this $110 in year 0. And I know from looking at this, we know that rate is 10%, so we should be able to figure this out in our heads, but again, let's not do that. So if we are going to discount back, we're going to have our amount divided by 1 plus the interest rate, so 1.1, and we're going to raise this to the number of periods we're going back. We're just going back 1 period this time, so this is just going to be 110 divided by 1.1. I know we can do this in our heads, but we need to get in the habit of not trusting ourselves, right? Okay, so 110 divided by 1.1, and what a surprise, it is 100, so most likely what we kind of thought it was before we did it, but we were just playing stuff. Okay, so our two different bonds have a present value of 150 or 150 together. Okay, so if we go over to the answer choices, we see that C, $150, is the is a answer, and it should be the correct answer. Okay, all right. So let's do another type. So let's see here. Let's do number 30. Okay, so I got a few emails about this type of question on the homework. So what you guys were missing is that I gave you guys some keyword to look for to know when to do certain types of problems. Okay, so the keyword is approximately. Okay, approximately. So if you see the word approximately, then that's going to let you know to use the rule of 72 or something like it. If we see the word forever, that means we know we're going to have a perpetuity. Okay, so let's take a look here and see if we can use the rule of 72 to help us out. All right, so suppose that we have Tim set aside $10,000 at age 20 for retirement. Lauren sets aside $30,000 at age 34. If both accounts grow at a constant rate of 10%, how much more does Tim have in his account than Lauren at age 69? Okay, so we're going to use rule of 72 here. Okay, so what does that mean? Well, we're going to basically see how long it's going to take for our money to double. Okay, so we're going to say 72 divided by 10%. Excuse me, 10. And that's not super clean, because that would just give us 7.2. We're looking for approximations here. So we could do this, but like I said in the video, sometimes we might use a different number if the situation means we can make a better division. So I'm going to assume from looking at this question that we should use rule 70 instead. Okay, so what's 70 divided by 10? Well, that's just going to be 7. So we're going to say approximately every 7 years that our money is going to double, and that's going to count for both Tim and Lauren. Okay, so every 7 years our money is going to double. Okay, so Tim sets aside $10,000 at age 20. Okay, So let's see, Lauren is going to set aside $30,000 at age 34. So it's going to double in 7 years. So let's look at Lauren. Let's draw a line graph here. So right now she's got 30,000. And let's put her name on here, or let's put her actual age on here. So she's 34. Okay. So in 7 years, she'll be 41. She'll have 6,000. Okay. In another 7 years, she'll be 48. She'll have 12,000. Okay. In another 7 years, so she'll be 55. She'll have 24,000. And another 7 years, so she'll be 62. So that'd be 48,000. And in another 7 years, that'll be 69. And so that'll be 48, 16, so 8, 96,000. Okay, so what about Tim? All right, so Tim is at 20, and he has set aside 10,000. Oh, there should be another zero on these, by the way. Sorry. Oops. 240,000. That's just 480,000, 960,000. Okay. All right. So let's look at Tim. So Tim's got 10,000 at age 20. At age 27, he's going to have 20,000. Okay. At age so that should be 34. He should have 40,000. So add another 7. So at age 41, he should have 80,000. Okay, so already he's looking better at that age. So at age 48, he should have 160,000. At age so that's 7, so 55. So he should have 320,000. At age 62, he should have 640,000. And at age 69, so we should have 640. Oops, 640. 08, so 1,280,000. Okay, so what is 1,280,000 minus 960? Let's see, so 0, 2, 3. So we should have $320,000 more than Lauren at that particular age. Okay. So that's really, and we could see this kind of applied in all sorts of other situations. Really, when you're using the rule of 72 or 70 in this case, you're just finding out approximately how long is it going to take for something to double. How long does it take for something to double? Okay, so our answer there is going to be 320,000. Okay. Yeah, that's pretty much it for that. Let's see if we can let's get some game theory questions in. right, so let's take a look at this one. Oop, hold on 1 second. Let me open this in a different app. So let's look at a few of these. All right, let's look at number 67. All right, so number 67 is just a regular payoff matrix. Remember that, oops, wrong thing. Remember that player 2 is column, player 1 is row. Okay. So what do we do when we're trying to find a solution, our solution concept, which is Nash equilibrium? We just hold our opponent's moves constant. Okay. So let's start with player 1. So we're going to put ourselves in player 1's shoes, and we're going to hold player 2's moves constant. So let's say we're player 1, and we assume that player 2 is going to choose left. Player 2 chooses left. I can choose up, middle, or down, or get 4, 2, or 3 as my payoffs. Well, 4 is better. I'm going to circle that. Now let's assume that player 2 plays middle. Well, I could play up, get 5, middle, get 8, or down, or get 9. 9's better, so I'm going to choose down. What if they play right? Well, I could play up and get 6, middle, get 3, or down and get 2. Well, 6 is the best option. Okay, so I've just given my best responses to all the different moves that player 2 can do. Now I just have to do the same thing for player 2. Okay, I'm going to put myself in player 2's shoes, and I am going to try to see what are my best responses to all the things that player 1 could do. So let's assume that player 1 plays up. So I could choose left and get 3. I could choose middle and get 1. Or I could choose right and get 2. Well, 3 is better, so I'm going to choose left. That just gave us a mutual best response. In other words, it's a Nash equilibrium. I'm going to put a star there. What if player 1 chose middle? Well, I would get a payoff of 1 if I chose left, 4 if I chose middle, and 6 if I chose right. So I'm going to definitely go right. And finally, what if player 1 chose down? Well, if player 1 chooses down, I could get 0 if I went left, 6, well, I don't want to circle that, 6 if I went to the middle, and 8 if I went to the right. So I'm going to want to go to the right. Well, we've gone through this. There's only one cell that is a mutual best response, and that is up left. Okay, so we look to our responses here, and we see up left is indeed one of the possible responses. Okay, so that's really all there is to doing that sort of thing. The only other types of questions I could ask are, well, what if something's a dominant strategy or not? So let's take a look at another one and see if we can figure out if there's a dominant strategy. Right? So let's do the same thing. So we've got player 2, we've got player 1, and let's just do the same thing. Let's hold our opponent's moves constant. So let's do player 1 first. So let's say we're player 1, we could choose up or down, and let's say player 2 chooses left. Well, if player 2 chooses left, if I choose up, I get a payoff of 1. If I choose down, I get a payoff of 0. 1's better. If player 2 chooses right, then I could get 4 if I chose up, and 3 if I chose down. So I'm going to play up. And notice that I'm going to play up no matter what. Okay, so up is going to be a dominant strategy. Let's see if player 2 has a dominant strategy. So let's put ourselves in player 2's shoes. So player 2 can choose left or right. So let's say that player 1 chooses up. Well, if player 1 chooses up, player 2 could get a payoff of 3 if they chose left, or 1 if they chose right. So 1 is going to, or left is going to be better. So they're going to choose left. That is a mutual or best response. That is a Nash equilibrium. Question wasn't asking for that. It was up here, I guess, but we weren't doing that one. And if player 1 chose down, well, I could get a payoff of 2 if I chose left, or payoff of 4 if I chose right. Okay, so player 2 does not have a dominant strategy. Their strategy depends on whatever player 1's doing. Whereas player 1 does have a dominant strategy because no matter what, they're going to choose up. So it doesn't matter what their opponent does, they're going to always choose up. Okay, so up is going to be the dominant strategy for player 1. Okay, so that's pretty much all there is for these normal form games. What we could do is do a simultaneous game, a sequential game. And so let's take a look at this one. So we've got a 2-player game. We've got player 1, which is Homer, and we got player 2, which is Barney. And remember, the key for the solution to these sequential games is to start at the end. Okay, start at the very last move. Right. So the last person to move is Barney, and Barney's got 2 different nodes. It doesn't matter which one we start at. We just have to do both of them. So let's see what Barney does. Okay, so Barney's player 2, which means these second numbers are going to refer to Barney's moves, the payoffs for Barney's moves. So if Barney does not enter, he gets a payoff of 0 if Homer chooses super. But if he does enter, then he gets a payoff of -1. Well, 0 is better than -1, so we're not going to enter. I'm going to draw a little arrow here to denote if we go down this way, Barney's going to choose not to enter. But let's say that Homer chooses normal, so that we're at this node right here. Well, if Barney chooses to enter, he'll get a payoff of 1. But he chooses no enter, then he gets a payoff of 0. So he's going to enter in this case. Okay, so we know what Barney's best responses are. Homer knows what Barney's best responses are. So we're going to roll back to his turn. So we're going to roll back to this this period. We're going to go backwards in time. And now Homer, the first mover, knowing what Barney is going to do, is going to make his decision based on that. Okay, so in other words, he knows that if he chooses super, Barney will choose no entry, and he will get a payoff of 2. He knows that if he chooses normal, Barney will choose to enter, and he'll get a payoff of 1. Okay, so, well, 2 is better than 1, so he's going to choose super. Okay, so our equilibrium, when we write it for a sequential game, it's got to include all of the possible strategies. Okay, so player 1, he could choose super or normal. He chose super. So Homer chose super. I'm going to separate the 2 players out by a semicolon here. Well, actually, here we just did it with commas. So let's parentheses. So let's just do that. And player 2, well, we have to put everything that they did. So player 2 chose no entry and enter. Okay, we're just going left to right here. So no entry and enter. Okay, so let's see if we can find an answer that says super, no entry, comma, enter. And let's see, super, no entry, that's not right. Super, no entry, entry. Okay, so that's going to be our choice here. Okay, so that's really it. If you can do any of those things, then that's really all the types of questions we're going to have. The more tricky types of things we could do is let's go over to this one. So some of the more tricky things we could do is maybe if we might have said for this problem, for example, maybe the first bond paid in time 3, okay, instead of time 1. Okay, so we'd have to adjust that. So if this paid in time 3, the first one paid in time 3, well, if we did this formula here to get that 50, well, that would mean in time 2, that's what the value is. And then we'd have to discount that back a couple of times. So we'd have to say, well, that's worth $50 in year 2, but today it's worth 50 over 1.1 squared, because we'd have to go back 2 periods. And so we'd have to say, well, that's worth whatever that is. So that's the ways that can get a little tricky. So you always kind of want to make sure you set up your time graph like this. But other than that, I mean, most of this stuff's pretty basic, and you're going to see the exact same thing each time. So just make sure you get enough practice in so you feel comfortable. All right, so that's pretty much it for this little review. I would suggest that if you have more questions, go ahead and email me, and if it's a big enough question, then maybe I'll send a response to the whole class, something like that. Okay? All right, so let me know if you have any questions, and come to my office hours if you need to, but I would suggest you try to contact with me beforehand so you can maybe get enough time in to study. Okay? Thank you.